Good morning and welcome to the AEE Canada East webinar for April. Today's webinar focuses on a really great project that happened here in the Ottawa area, and it was a net zero energy and carbon retrofit of a community housing building, which is a great story to tell. Before we get going, we always like to give a shout out to our sponsors. So chapters like ours can't function very well without the support of organizations like these. We've been really lucky for our chapter for all of the years of our existence that we've had a very strong stable of companies that stand behind us, lend us their name, lend us their support, and of course fund some of our activities. So give a big shout out to these guys. If the company you work for doesn't show up on this list and you want them to, please reach out to us. Information about sponsorship is on our website, so you can feel free to converse with us on that matter if you wish. Of course, we are a chapter of the Association of Energy Engineers. The association has been around for a long time, started in 1977. In fact, this is the 45th anniversary year. And we are really the local embodiment of the association. So we always like to recognize that as well. It's the reason why we're all here. And without further ado, we're going to get rolling today. I'm going to ask Rob Rousseau from our chapter board to come on and introduce Dan.
Thanks, Andrew. Dan DeCare, he has an undergraduate and a master's degree in chemical engineering from the University of Ottawa, and he's a professional engineer and certified energy manager. Dan works for community housing, Ottawa Community Housing, and as manager of energy and sustainability there. He has coordinated the installation of 500 kilowatts of solar arrays, managed a portfolio-wide LED lighting retrofit. He's also supported the development team to produce Ontario's first mixed-use passive house, and is currently part of the team that is constructing Canada's largest passive house building at 811 Gladstone. He's also working on OCH's zero GHG retrofit strategy for their 15,000 units, which started with the Preston net zero retrofit, which we'll be discussing today. And under his guidance, OCH has saved over $46.5 million in utility costs. And in 2020, Dan received the Association of Energy Engineers Young Energy Professional of the Year Award for Canada. And probably most importantly, he's a proud father of a lovely 6-year-old daughter. So thanks very much, Dan. Welcome, and I'll pass it over to you.
Perfect. Thank you so much for that introduction, Rob. And thank you all for being here today. I'm extremely excited to share this project. It is extremely close to my heart, and I think it is kind of the way that we should be going. So, all right, fantastic. Like I was saying, thank you so much all for being here. OCH is extremely excited to just share as much knowledge as possible on this prefabricated exterior energy retrofit that we did at the Preston project. This was a partnership with Natural Resources Canada, so about $500,000 of funding came from Natural Resources Canada, and we're also actively working with their buildings group in order to keep doing the monitoring. They were instrumental in some of the design components of this, and it's just a really great partnership that we hope will continue in order to spread this type of project as far and wide as possible. So without further ado, I will just give a little bit of an introduction on Ottawa Community Housing itself. So Ottawa Community Housing, we are Ottawa's largest landlord, the second largest social housing provider in Ontario. We've got about 15,000 units. And those 15,000 units are in about 100 high-rise or mid-rise communities and about 60 townhome communities, which will be, like 50 to 100 to maybe even 200 townhome units in one community. One thing that is extremely pertinent about our portfolio, it is over 50 years old for the vast majority. 2/3 of our buildings are over 50 years old. The vast majority of it was created, like most of the social housing in Canada, in the 1960s and 1970s. And up top in the right-hand corner there, you can see our utility consumption for the past 10 years. And one thing that we're kind of proud of at OCH is that we've been managing to keep that, I'll call it fairly stable in terms of cost, at least, somewhere between that $23 to $25 million a year. And the way that we've been able to do that over the past 10 years is with some of our retrofits, some of the low-hanging fruit, if you will. So some of that $46 million that we've saved over the past 10 years has been through boiler retrofits. Or one of my favorite pictures, that's one of our project managers standing on top of 3,000 toilet seats, because we did a complete in-suite plumbing retrofit where we replaced over 16,000 toilets. And that has been saving us a great deal of money. Then on your right, another example of how we've managed to keep those costs even is our Regina Lane solar project, which is an array of 150 kilowatts. It's the largest in our portfolio, but we've got 500 kilowatts of solar generation all throughout the portfolio. And it's with these types of more standard energy efficiency, your boiler retrofits, your added insulation, your all that kind of stuff that we've managed to keep, and the LED lighting retrofit and things like that, that we've managed to keep our utility costs fairly stable. But our world is changing a little bit as let's say, run out of those low-hanging fruit, and we start to look at carbon as well as the energy efficiency and what our portfolio needs to transform into. So specifically looking at a little bit more at the local context, but really I feel this is applicable to pretty much anywhere in Canada. We've kind of got a housing crisis going. So on the left, that graph shows the median income of a household to the median cost of a house. And we can see that it's, I don't think it's any surprise to anybody that that's been increasing significantly. And in fact, this is now an old graph. I'm sure it's even more steep nowadays, where it's getting harder and harder to afford housing. Most of the new housing that's being built is out of, for example, in Ottawa, of the 5,000 to 6,000 units that are produced every year, only about 1% are in that affordable range, as defined by CMHC. So then we realize, hey, then it's really important to keep that 15,000 units of housing stock standing, and so that it's available as a service. But we also realize that that is now a 50-year-old housing stock that needs a lot of love. And so, okay, well, now we need to find ways of financing and keeping that very important stock alive and well maintained. And we also know that if we're going to do some of those maintenance pieces, we're going to have to do them while the tenants are in place, because we don't necessarily have any other affordable housing to go put them into. We've got this limited 15,000 unit, 15,000 units. And then we get into, well, and then how are you going to find the financing for this? Because most of the programs that created this housing, we call these funding agreements, they're expiring in terms of they've lived out their life. And now we need to look at how are we going to be financing the ongoing maintenance as well as the ongoing operation of all these buildings. So we've got these delightful kind of meeting of these challenges in this housing crisis right now. And then we turn to the right-handed graph, and we see we're in a bit of a climate crisis, where we know that we've got these very aggressive targets in order to meet our 2040 or 2050, depending on which IPCC report you want to be referring back to. And what we have on the screen right now is the City of Ottawa's Climate Change Master Plan. Basically, this outlines how much each of the major sectors in Ottawa need to save in order to, or need to reduce their GHG emissions in order to hit that 2040, that 2050 target. And very important is that 1/3, about 30%, comes from existing buildings. So those 15,000 units that OCH owns that were built in the 60s and 70s, they make up that very large portion with contributing to the existing buildings. So we have this delightful meeting of these two crises, but in all honesty, it represents such an amazing opportunity for us, because we can address kind of both of the housing crisis and the climate crisis and these energy consumption issues, all with one type of project, which is kind of what we've been working on right now, and what we hope to be doing much more of in the future. So the answer that we are kind of proposing is this example of a prefabricated exterior energy retrofit. What we have in front of us right now is 197 to 203 Pressland, 4-unit block of townhomes with 3 bedrooms each, 2 stories, built in the 1960s. Annually, this building cost about $7,200 in utilities, and it emitted about 18 tons of CO2 every year. So all the domestic hot water, as well as the furnace, was natural gas. And now we go to what this building is today after the retrofit, which is it's still 4 units, 3 bedrooms, renewed in 2020. It is now net zero energy annually, able to generate as much as it's going to consume. And most importantly, it emits 0 tons of CO2. And this entire retrofit that you have in front of you was done while the tenants were still in the suites. So put that all together, this represents kind of the approach that we see how to answer all of those crises with this one great project and opportunity. So let's get into the nitty-gritty of how it was done. The first step, what you have in front of you right now looks like a picture, but what it actually is a LiDAR scan of the building from front and the back, which is basically a point cloud of every single thing that's on it. You even have, for example, the satellite dishes and all the edges of the windows. We scanned the building in order to get an extremely accurate picture of what this building was, where it was, and where all the details were. Because if you're talking about making some sort of prefabricated retrofit to put on top, you need to be really, really sure about exactly where your doors are, exactly where your windows are. And from this scan, we get this, which gives us exactly all those measurements that I was describing, where the doors are, how big the windows are, how big we're going to be making our panels in order to fit them over the existing building. So that is the first place to start. Now you can build up your panels. You can start to design what is going where. So now what are we going to be putting on top? Well, we now have this elevation side view of the building where we see all the way down to our foundation. The first step is eventually we're going to be, we take off the eaves trough. We take off the eaves in order to make it just a box on top of which we're going to be building a brand new building envelope that goes all the way down to the footings. So when we're below grade, we're excavating all the way down to those footings. We're going to replace the weeping tile in order to make sure that we address any sort of water egress issues. Putting a membrane, that purple color that you see over the brick represents a waterproof and air barrier that will make this foundation as airtight and water resistant as possible so that we address any further water egress issues. On top of that, we're putting 8 inches of insulation so that we give that foundation as much of a thermal barrier as possible. And as we get above grade, you see these brackets that are going to be supporting beams that are going all the way around in order for them to support a above grade panel, which looks a little something like this. So now we are above grade, and these are basically SIPS panels that are stitched together to form these mega panels of 20 by 9 foot. Basically, the entire width of a unit is covered by one panel. And you have the SIPS in the back. You've got the windows and the doors that are cut out. You've got your air barrier membrane that we can now tie back to the below grade membrane. And we're trying to finish these panels as much as possible. So you put your strapping, you put your siding on top. You really want a finished product so that you do as much of it in a prefabricated context as possible. And that's what goes on the building at the first level, the first story. Then we have a similar kind of a beam that allows us to add the second level. So that second level panel is going to look much similar. And eventually we get to the roof where we are basically going over the existing roof with that air barrier membrane that allows us to make an entire building envelope that's very tight. We're going to add a new roof because we also need more room to add insulation. So we're adding about 16, 18 inches of insulation. And the existing, so we're going to need to do that on top of the existing roof, which means we need to build up that roof, and it'll allow us a better slope to add solar panels. So now we've got a brand new building envelope, which means that we've reduced the energy consumption by a great deal, which means we can take out that natural gas furnace and that natural gas hot water tank and replace it with air source heat pumps and an ERV. So now we've got a heat pump for the domestic hot water, a furnace that is heat pump, which means we're also contributing, we're adding heating and cooling to these units. So there wasn't any central cooling before. Now these units have central cooling. And obviously, since we're tightening up that building envelope so much, the ERV that we see in that the right-handed picture, that little green stripe on the beige box, that's the ERV that is now very intentionally delivering fresh air into the building and exhausting the old air in order to ensure that we've got good air quality within the building. But now, obviously, we've removed natural gas, which represented a huge load for that building. We had a 100-amp panel before, but now we're adding all of this electrical equipment. So with this retrofit, which started as a building envelope retrofit, which became a mechanical retrofit, also needs an electrical retrofit. So we needed to upgrade the service. We need to upgrade the individual panels to 200 amps in order to accommodate these added loads for the electricity. But that also meant that we needed to upgrade the transformer which served these buildings. And as well, we're going to be adding solar in order to generate as much energy as we're going to consume in a year. So for all these reasons, it also required an electrical upgrade for this building as well. Now, if we want to get into a little bit of the details, so here are some of the stats from our base case to the net zero retrofit. So you can see that we've significantly increased the attic R values as well as the wall R values. Our air tightness, we didn't quite hit our 1.8. We were around 2.1, 2.2 at air exchanges at 50 pascals. Obviously, the heating and cooling has gone from natural gas to electricity. Ventilation added active ventilation with the ERV and the domestic hot water. And obviously, there wasn't any solar panels on the building before, but now we've got 34.8 kilowatts of solar. So what does that represent in terms of the actual energy use? So modeled over a year, our space heating demand has drastically dropped by about 90%. Compared to what it was before. Similarly, our domestic hot water has significantly gone down about 80%. Lights and appliances, this is staying fairly similar in that we didn't do too much of a change for that, as well as the ventilation. I mean, before we had the furnace running anyway, so not a whole lot of change. A significant change, however, is that now we have cooling, which is something that wasn't there before. But similarly, generation, which represents a negative in this particular graph, wasn't there before. And when you take the overall net energy balance, you realize that we are slightly positive. So essentially achieving our net zero goal for this building and eliminating all the greenhouse gas emissions while we're at it. But obviously, none of this means anything if we can't quite prove, or we need our key performance indicators in order to guarantee that we've actually achieved our goal. And the way that we've split these three things with NRCan, who's doing some of the monitoring with us, in basically indoor air quality, there's energy, and there's also durability. So indoor air quality, I mean, it goes with that. We're monitoring CO2. We've done radon tests before and after to make sure that there wasn't any radon concerned, as well as, you know, temperature and relative humidity, how comfortable the units are remaining. Energy is obviously one that's front and center. So we've got CTs pretty much everywhere. Every major piece of HVAC equipment and the domestic hot water and all that has a CT on it. We're also monitoring all the base loads or the plug loads that the tenants are consuming in the building. And then the PV generation, how much are we actually generating every single day from those solar panels on actually this beautiful Ottawa day that we have today. And the last thing that's being monitored is the durability and resiliency. So throughout the panels, NRCan actually put in some of our assemblies, there are sensors, humidity sensors and temperature sensors in the in every single like layer of the SIPS panel, as well as in the air gap and all that kind of thing, to make sure that, in fact, we're not creating conditions for mold, that we are in fact achieving the targets that we wanted, and just making sure that the durability that we've planned, because this is supposed to be a solution that is going to revamp this building for the next 50, 60 years. So we want to make sure that the solution that we've provided is in fact going to give the building that lifespan. As I mentioned, we've got some ongoing monitoring. I know this is always a question, so we don't have a full year of monitoring quite yet. We're still working on it. In fact, it'll be done in September 2022. But I'd like to give this little snapshot because there's always this question, hey, Canada, we are cold, especially Ottawa is delightfully cold. Can this actually make any, like, can we actually provide our heating through this system? And clearly over annually, it makes sense. But I also like to show this particular day. So January 11th, 2022, this year, it was -23 before the wind chill in Ottawa. But that also means that was a perfect generation day for the solar, because there is not a cloud in the sky. There's no humidity in the air at -23. So there isn't a cloud in the sky. So you can see on the left-hand side there, that is a beautiful generation curve from our solar. 142 kilowatts generated that day during the time that the sun was out. And then on the left-hand side, you have our CTs that are monitoring all of the energy. And basically what happened that day is that our solar generation managed to generate 88% of the heating needs were covered that very day by that solar generation. So obviously there's still there was plug loads and all of the other things that needed to be done. And clearly we over generate in the summer and we're under generating in the winter. But when you see this, you realize, hey, when you retrofit a building like this, you can actually not only achieve net zero, but you're really reducing the overall load on the grid, especially when we're talking about electrification and getting rid of natural gas and reducing GHG emissions. So this is just basically a little bit of a taste on the monitoring that says, yes, this is possible. So now I'd love to get into a little bit more of the actual nitty gritty. I'm going to show you some of our fabrication facilities. And this is where I really want to highlight the absolutely amazing work of OCH staff. So the vast majority of this project was done in-house. So we had an extremely talented development officer, Keith Gagne, who's no longer with us now, but who was managing this team of 3 extremely talented carpenters, who basically built, and you're going to get to see them in the videos, who built all of those panels, who manipulated them with the telehandler, who installed them onto the building, who basically, like, we built this manufacturing facility out of 2 sea containers and then some trusses. There's some pulleys in the ceiling so that we're able to manipulate these giant panels and move them around and do all of the work ourselves. And in all honesty, it helped to have it really close to the chest, because we were looking for such specific results. And anyways, the industry is adapting, but we really wanted to make sure we had that quality control and that monitoring piece in terms of adding sensors and things like that. So it really helped to have all of this done in-house. And the last thing I'm going to point out is that table that you see in the picture. That is a giant rolling table, and the middle comes out of that table. So we were actually able to use that table to fabricate the panels, but then also do cuts right into the middle of our panels to get those windows and doors. And you'll get to see all of that in the time-lapse video, which I'm going to jump to right now. So if you'll just give me 1 second, I will switch from that. And I believe that we're still good in terms of seeing the screen. So what I'm going to show you is in 2 minutes what happened in over a year, basically. And I'm going to talk really, really fast. So what we have in front of us right now is 197 to 203 Pressland, how it was before. Now, first, obviously, we won't go down to the footings. We excavate all the way down, replace the weeping tile to make sure that we don't have any new issues with water egress. That exposes the foundation, which we can now cover with a waterproof and air barrier. And then we put in those 8 inches of insulation and backfill. Now we see the cement cuts that are going to make way for the brackets in terms of being able to add that above grade beam that is going to support all of the above grade panels. Now we are in that fabrication shop with our very talented carpenters who are stitching together these SIPS panels into 9 by 20-foot panels with the windows and the doors already cut out. To those new mega panels, we add the air barrier membrane, and then we do the strapping. You see the strapping as well as the siding that's getting put on. So you really want a finished product, as much of it prefabricated, and then being handled with our little telehandler. This is then being delivered to the actual site and then being put onto the building. So in one day, we managed to put on 8 panels. You're going to see most of them here. But it was a very, very quick process, and there's 24 of these prefabricated panels going around. Now that we've got a new building envelope, obviously we're able to remove the existing furnace and the natural gas furnace and the domestic hot water tank and replace them with the heat pumps. So as I was mentioning, 24 panels go all the way around. We managed to tie them to that below grade membrane and tie them all together to make a new building envelope. As we get to the roof, we keep that air barrier going over the roof with spray foam, and then we add insulation on top, build the roof up. And once that roof is up, we're able to add that 34.8 kilowatts of solar panels on the south facing roof, which is generating as much power as the building is now consuming. So our building envelope reduces the energy, our heat pump system delivers the energy that's necessary very efficiently, and finally that 35 kilowatts of solar generates all that energy, as much energy as we're going to consume in a year through those solar panels. And here we have our official NR Guide rating of 0. So officially a net zero building, if you will. So now, if I'll just pop back into my presentation. Perfect. And I know now the question on everyone's mind is, fantastic, we did it. You hit net zero. How much did it cost? And here, we're also talking about a pilot project, and there's a lot of additional monitoring and additional consulting, if you will, that took place that you wouldn't have even in a normal project. But here's how we've been looking at it in terms of a payback period or an approach for the financing. Especially when you're talking about building in energy savings and GHG, eliminating carbon, we're talking about long-term projects, right? Like if we're talking about all the way to needing to hit our near zero GHG emissions by 2050 in order to not have a problem in when we hit 2100 effectively. The way that we've been approaching this is with effectively a net present value of 60 years, or what we like to call a total cost of building ownership. So what you have in front of you right now is what the existing building's capital plan was for the next 60 years in dollars. So, and you really, when you do a total cost of building ownership, you really have to, to include every single aspect of what you're going to spend money on in that building. So you can see there, the biggest components are energy costs of that existing building. And that represents those green bars that make up the vast majority of the expenses. The next biggest one is maintenance and repair. So those red lines represent all of the big capital. So window replacement, roof replacements, furnace replacements that'll happen multiple times over a 60-year period. Basically, those are all itemized throughout the life of the building, and they represent those red lines. Now, obviously, there's other things like home insurance and interest and property taxes and GHG costs and things like that we're trying to represent. But overall, those are the two major components. Now, that was our existing building. We knew this is how much money we're going to spend. And that's actually why this exercise is so important, is that often people assume that the status quo is people don't realize that there is a cost associated to doing nothing. There is a cost to your status quo. And in fact, this shows us that. And the actual answer is, when I look at the net present value of this, it represents about $2.5 million over the next 60 years for this building's lifespan. So when you realize, hey, I'm going to spend millions of dollars on this building, well, then you start to ask yourself, okay, well, what would be my alternate option? And the net zero retrofit that we showed today is that answer. So we start the graph now with that very large major building renewal, that new dark blue line. It is obviously a very big expense. But what it does do is that it effectively eliminates, because there's still some costs associated with energy, but that total energy cost is now minuscule across the entire life, the next 60 years of this building. And obviously the maintenance and repair, those red lines, they don't completely go away. We have managed to take advantage of the major building components and try to just accelerate it and do it in year one. So the overall maintenance is reduced, but it is absolutely true. We have to recognize that we will still be spending money on maintenance and repair for this building over the next 60 years. Now, what does this represent? So the first column is our base case of that existing building. Vast majority of the costs associated with operating this building over the next 60 years would have been energy costs, followed closely by the maintenance and repair, as well as property taxes and home insurance, but also not forgetting about that 18 tons of greenhouse gas emissions that were being emitted from this building every single year. Now we compare that to the total cost of building ownership of our deep retrofitted building with solar. So now we've reduced the overall energy cost to as small as it could possibly be. Yes, we've added that major building renewal, but we've also reduced the overall maintenance and repair for that building. And your home insurance and your property taxes are still fairly similar. But so now we've brought that just above $2.5 million over the next 60 years to just above 2 million. So we've effectively saved $500,000. And it's important to compare these with some of the other scenarios. So for example, let's say that we just said, solar is too expensive, or it doesn't really, we just want to electrify, which is sometimes the way that some people approach the situation. We can see that just electrifying this building with a more expensive fuel, which is electricity, which electricity tends to be, would have actually resulted in higher emissions. And then we're just on the grid. So higher overall cost and still some emissions because we're still using the grid, which has a natural gas component. And then the last scenario that we have here is this was a pilot done by internal resources. I have no doubt that there are very smart contractors out there that can look at our process and say, oh, you spent too much money on this, you did this. And not only that, we only did 4 units. So imagine when you say, let's do 200, let's do 500, let's do 1,000 units. We anticipate similar to the Energy Sprong model, after which this retrofit was modeled, that we will be seeing some 30 to 50% cost savings over the overall project. So, and in that case, we might actually be looking at $1 million of savings over the total cost of building ownership for these buildings. So it's really important to put that into context. So now we've finished our first deep energy retrofit. We're doing that monitoring that we discussed. What comes next? So we are extremely fortunate. So OCH has been working very hard so we've got our implementation group and trying to figure out how we are going to do the portfolio renewal that we need to do and how we're going to tie it into the energy efficiency and the GHG reduction goals that we have. We currently have secured about $220 million from CMHC's National Housing Strategy, the co-investment fund, in order to do that asset renewal of about 24, well, it'll touch about 10,000 units of social housing in Ottawa, but it comes with caveats, which is that it also has to reduce 7,000 tons of CO2, and it has to reduce our overall energy consumption by 45 million equivalent kilowatt hours. So the way that we're approaching this particular challenge is, well, as opposed to going and getting that from all of those 10,000 units, we're targeting a lot of the work in about 2,400 units, where if we go and do a full deep energy retrofit in these buildings, they will be good for the next 50 years. And then they provide the savings for all the other 7,500 units. So we get the overall funding envelope, get to do our renewal, but we get to do a few deep energy projects. About 12 to 15 projects are going to get, communities are going to get that deep energy retrofit treatment. And then, well, eventually we got to get the rest of the portfolio, so that there's an estimated probably another $750 million, so $750 million of outstanding investment that is required somewhere in the next 20 to 30 years in order to meet those climate change master plan targets for the city of Ottawa, or whether you want to, we are also signed on to the Race to Zero target, which is targeting actually 2040 as eliminating all of the GHG emissions. But really all of these things, they all come back to the IPCC's 1.5 degree Celsius scenario, which is effectively what all of Canada, all of the world needs to meet. So some amount, some version of what we just showed, I hope that people are looking at this and realizing, and they're seeing their own buildings or their own city in this, because at the end of the day, what I'm showing today in terms of the stats is applicable pretty much everywhere throughout Canada. So now just to give you a taste of where we're targeting. So I showed you a block of 4 units. This is our Britannia Woods community, which is 179 units. And this is where we're targeting our efforts for the low rise right now. We're looking at how can we do that deep energy retrofit on a larger scale for this entire community. And obviously, when we went to Pressland, we were doing a more individual modular approach. So we had individual air source heat pumps. We had individual solar systems connected to the individual building. But when you're talking about an entire community, you can probably go with a little bit more of a district approach. So obviously, we're still going to do that building envelope retrofit. That is where you get the bulk of that reduction from the beginning. But then you start thinking, well, do I need to do individual heating systems, or can I go with maybe a more centralized approach that's going to bring maybe having a centralized geothermal system, a ground source, so that I've got a better COP instead of individual heat pumps? What can I do in terms of my distribution? Can I maybe save space and both physical space in the basements as well as on the electrical panels by just putting in heat exchangers in all these buildings rather than actually putting in heat pumps, right? And then we get to the exact same questions on solar, which is all of these buildings' roofs are going to need some amount of solar in order to meet that net zero target. But whereas we were just talking about 35 kilowatts at Pressland, when we're doing this to 179 units, we're talking about over a megawatt of generation in a very urban setting. So we're definitely talking about messing with the existing grid. So we're going to need some way of doing some demand response and adjusting to the inherent intermittency of solar generation. So you start to look at this as a much larger scale project, and you start to see some of the efficiencies and the ways that you can integrate when you're not just talking about one unit, you're talking about neighborhoods. And luckily for this example, there's one owner, it's OCH. And so we have, I'll say it like we've got that control over all those units. But I think this model is actually applicable to normal, maybe with a little bit of finessing and the contracts look a little bit different, but we probably need to look at something similar for our normal neighborhoods, perhaps in new developments or even in retrofit scenarios. So that's the low rise, but we're also targeting some high rises. So right now there is an RFP out for the design of this particular building, trying to do, this is 303 King Edward, which is a 3.5 story walk up, 40 units, but a perfect square shape that you can already see that it lends itself extremely well to that same kind of templated panelized retrofit that we showed for Pressland. And we're looking at this building saying, okay, how can we do, what does the build, it's currently out for RFP so that we can get a consultant on board that is going to design those building envelopes. That's going to design the new heating system, how to integrate the new cooling, how to do heat recovery ventilation, and how much solar are we going to be able to generate. And the trouble is, as you get into higher density, so 2-story, yes, we were able to do net zero. The energy density of that particular, building, you're able to get it through solar on the roof. As you get into any sort of high rise, so we're in 3 to 4 stories right now, we're not, that energy density is getting higher and higher, and we're not going to be able to reach net zero on this building just inherently because of how much consumption there is on a smaller footprint. And then obviously that question translates even more because this is another building that's going to be in the second half of 2022. That RFP is going to go out, where we've got a 15-story high rise where we need to once again do the exact same deep energy retrofit that entire building, but we're achieving the footprint of this building is not going to yield any sort of significant solar generation. So we're aiming for that really high energy efficiency on the overall building envelope, as well as energy efficiency with the mechanical systems. But this is where net zero starts to get a little bit away from us, because we're not going to be able to generate nearly enough with the small footprint of solar. But these are real projects that we are currently in the process of creating scopes of work. And yes, OCH is in the process of trying to take the lessons learned from that Pressland project and roll it out to about 900 low-rise units and about 1,500 high-rise units like this. So thank you so very much for your attention. If you're looking for more information, both either from OCH's project on OCH's projects or on NRCan's research that's taking place, I've got some links in the screen there. And so myself, Mark Carver, who's over at the CanMet Energy, and a very special thanks to Keith Gagne and Jeff Armstrong from Cold Climate Building is the one who helped design the panels, as well as Peter Amarangan, who's actually doing a very similar project. Basically, they're doing this over in a co-op out in Alberta, and they've got I think now they're in the 12 units under their belt of the overall about 40 that they're going to be converting using a very similar method. They're going for near net zero. But yes, very, very exciting. There is a lot of this going around. So thank you so very much for your attention.
Well, that's really great, Dan. I mean, you kind of have me a little bit speechless, because the presentation buttons it up so nicely, and almost leaves you just wanting to go and do this to every building in the city. But there are a few questions that have come up throughout the presentation. So thanks for being so thorough, but we're going to ask a few questions still. Mm-hmm. So one, and we're going to get it out of the way real quick. Just, can you remind us what the orientation of the building was?
Yes, so it was a perfect southern orientation. I don't believe I have an actual
like Pressland is an east-west route, right? Pressland is east-west, so it's...
Yes, Pressland is east-west. This, I'm just going to go back to our, but it has a perfect southern orientation. It's very much an ideal building.
Right, okay.
Yeah, so sorry, actually, yes. So if we see that, like, literally north, south, east, west, it's one of the most perfect orientations.
Yeah. As near perfect as you're going to get in our urban planning environment.
Yep.
That's awesome. Okay. So as you guys were going through this, and you're contemplating going the route of prefabricated panels, the SIPs, and you probably evaluated maybe a bunch of different configurations. Did you run into any challenges with the authorities having jurisdiction, or how did that look for you?
Yes. So it took a very long time to get that building permit. I will not lie. And I mean, there was also competing factors, as the vast majority of this project was also done right during COVID. But so the first question that came up when we made this application was, well, wait a minute, do I treat this as like almost a new building, in all honesty? Like, should I be looking at this as a straight up like a Part 9, and therefore you got to look at it? Or can I just no, we're actually just doing an overcladding. And therefore just go to our, so it was, we did go back and forth. We were lucky enough to have a little bit of support from an old building inspector that helped us frame this and show, no, here's the things that we're changing. And we try to engage the building inspector as early on in the process as possible. We even sent them like some drafts of the drawings so that they knew what they were getting into when they received it, and they weren't kind of surprised. They came out to site a couple times, and even to the prefabrication facility, which also helped them understand what we were doing. And overall, once we got that building permit, it was being framed this is not new construction. Yes, this is a retrofit, and it's more of an overclad approach than anything else. But very much, it looks so different, right? Like, you could argue that there's an entire shell of a building on top of like a new shell that's on top of that existing one. So it helped to engage early and often.
So just help us understand too, like you're probably in a lot of these conversations. What were the authorities tripping over? Like what was giving them heartache or heartburn?
Well, so it's basically like, okay, well, we now have, okay, hold on. I'm just going to jump back here. We now have arguably a concealed, unventilated space in the middle of this building, right? So the old attic is now part, and in all honesty, the way that we saw that is, well, check it out. If I take out the attic hatch, or if I vent the attic hatch, all of a sudden, do we agree that that is no longer unvented concealed space? It is still like it is now part of the existing. It is part of the existing conditioned space. Similarly, the roof was one of the challenges as well, because it's like, well, hold on, you have you have an existing roof. You're literally adding a whole new. This is one of the things that kind of triggers that aspect of, well, is it a new building? Because your the cladding, you can argue that the walls, yeah, it's just cladding, yeah, but it's 18, it's 12 inches of it. The new roof was one that they really needed to see very detailed explanations of where we were going to be connecting, because you're also connecting to an existing building, right? Whereas when you submit new plans, you're like, okay, I can clearly see where this weight of the roof is being transferred all the way down. Whereas now we're like, okay, we're using an existing structure and we're transferring the weight to these places. So we basically we had to cut the roof and go down to the shear walls and build up those shear walls. And then we've got LVLs going all the way. Like there's these giant beams basically going all the way. And as a result, there's very much an argument that there's parts of this that are probably over-engineered as a result. And that's where I was describing, there's probably smarter people, smarter people might look at this and go, okay, this is what you were trying to do. Well, you should have just done this and this, and don't bother with this heavy beam that, yes, I see what you're trying to do in terms of transferring the loads, but you could have done it like this. It was those types of these places where the new building meets the existing building, and how do I know that that existing building is in fact going to support that load?
Yeah, right on. And I think those insights are perhaps some of the most important, Dan, because if you're talking about transferring this and applying it to different communities, not only within our own jurisdiction here in Ottawa, but more broadly, right, to other jurisdictions, you need to be able to prime these new developers with those tripping hazards so that they can avoid them, right? Or they can do, as you say, that look for the next innovative way to tackle that problem.
Yeah.
So kind of as a carryover from that conversation, I mean, you're talking about kind of wrapping this building. Did the entire existing envelope essentially remain there?
Yeah, so that is an excellent question. We took the approach on this one that we were leaving the existing envelope there. So the brick cladding is still there. We didn't do anything to that. That was decided at the beginning of the project as we're going to try to reduce waste. We're going to try to reduce amount of time on site. We're going to try to reduce disruptions of demolition. That brick definitely causes a few hiccups in that if it gets wet, it is going to hold a lot of moisture. It's old brick. It's very porous. And as we were doing our cuts in order to make access points for the beam, as we were doing our cuts to get rid of the sills, as we were doing our cut, and we started to realize that, you know what, we probably would have taken down, if we could do it again, we probably would have taken down that brick. Then maybe we don't need the beam because then we can go, 3-4 inches onto the existing foundation and give ourselves leaning there. Maybe we need to just add a smaller bracket. Maybe then we can use some of and then we get to see the real condition behind every single one of these windows before we're replacing them. We've realized that for at least this type of building, we would have probably removed the brick if we could go back. But it was that exercise of trying to leave it in place, less to the landfill, and get in and out as quick as possible.
Yeah, right on. It's always hard being the leader, isn't it?
Well,
you have to learn all these things for yourself. You don't have a peer that you can look to necessarily.
and I hope that as people look at this and say, take those lessons and maybe judge us a little less harshly when you go, how did you miss that? Well, yes, there's a lot of things that we probably could have done better, and that we will do better, in all honesty. And the important thing is very much sharing these results.
Yeah, absolutely. I can't wait to see how this translates to Britannia Woods. It was right.
Yes,
the next,
exactly.
yeah, that's going to be fantastic. So when we wrap this building with these great sandwich sips, um, can you describe to people, what happened with the door and the window placement? Because now you're adding what, 7 inches of thickness to the outside of the building.
Yeah. So how about this? Our panels are the SIPS panel is basically 8 inches, right, between your two OSB and your insulation. We added what we call a squishy layer, basically 2 inches of fiberglass back to the back that would help absorb any sort of irregularities in the building. But then you're putting so now we're at 10 inches effectively, and then you add your strapping and you add your siding. So you're somewhere between 10 and 12 inches added on. The most important thing is you line up your door. As we were doing all of this, the math, it was like, no, the doors need to line up. Everything else can kind of be corrected. So that is where we had our least margin of error. And pretty much every single one of these things, except for one panel, lined up within a 1/4 inch of where we wanted it. We were able to, you make that door just maybe a little bit. The doors are the ones that we didn't have as much play, but your windows, you can always make a little bit smaller in order to be able to do your finishing. We had one window that basically was a little bit, it was basically like 2 to 3 inches off, and we needed to kind of just adjust where the panel, well, we lined up the door and then we cut into our panel to make, and basically put it on that side over to that side. But yes, the answer being, you need to line up that door is the most important thing. Then the other thing that we gave ourselves as a buffer is that we planned for 4 inches between the panels, so that we had enough room. So, I mean, some people go like, hey, we're going to try to line each adjacent panel down to, 1/2 inch or 1 inch. But then if you end up using it, you can't really work in that space. So our approach was, we'll line up the doors, and then we will intentionally leave ourselves 4 inches between every single one of these panels, so that we know that we've got enough play. And when we take advantage of that, we can actually go in and basically we went in and added in, we put splines down, we added the insulation, and then we vapor barriered over that on site. And that gave us an extra finish, just to kind of give ourselves, that template is now much more useful because it can move around much more and it doesn't need to be as precise.
Yeah, right on. And then for the windows themselves, like, did you pull them out? Did you pull them out from their existing location towards the exterior skin?
Yeah. So from our hygrothermal modeling, it suggests you definitely want to bring that the window into that new building envelope, but as far recessed back. So literally the way that we did it, the old windows were still in place. You put the panel on top. Then on the day that you are ready to install your new window, somebody goes in, rips out the window. You basically finish from the outside all the way in with a nice piece of plywood or something. You bring it all the way in, and then you add that new window in that new envelope layer, and then you finish to the inside with a little bit of molding. So you've made a slightly smaller window, so you had some room to work, but we've added bay windows to pretty much every single one of the windows as a result.
I was going to say,
there are other projects might put the windows in the actual building envelope right in your new panel right from the beginning. We decided not to do that, we were the ones doing the transportation. We're not super familiar with how we were going to move them around. So we wanted to be a little rougher with the panel, or give ourselves the opportunity to be rougher with the panels. But definitely you could also just have it, if you've got the person inside ripping out the window as you're installing the panel, you could be doing it on the same day and shipping with windows in.
Yeah, right on. That's really cool. So now basically what you've given them, all those south-facing windows, you've got a bunch of little gardens probably, right? Everybody's got their plants lined up in there.
Oh, very anyways, one of the tenants
awesome.
really like that aspect.
Yeah, that's cool. So that's a great segue. So the tenants. So, you described throughout your presentation that, one of the one of the reasons why this was possible for you is you had full ownership, full control, right, of the asset. But you also said that the people that are living there, continued to live there throughout the process. So did you do any pre and post surveying? Like, how much were they involved in this process, and how much input or how much feedback did they give you?
Yes. So, I mean, the tenants the tenants have been absolutely amazing. They lived through a science experiment, and that is like, I very much say it like that. So they have been amazing, and in all, like they all, I know them all on a first name basis. They all have my cell phone number. So it was also useful because when something went wrong, I knew about it. So the since we don't have any way of displacing right now the tenants, and we want to do these types of retrofits, the idea of a prefabricated retrofit helps us do as much work offsite as possible, try and show up and do the retrofit as quickly as possible. We did do some pre-surveys in terms of trying to understand what types of air quality or comfort that they had in their current building and their current unit. And we are doing post retrofit occupancy surveys to try and figure out how things are operating. The one biggest thing is that they have central air conditioning now, which has been the kind of biggest selling point of thank you for sticking through this project with us. Now you've got central air conditioning. Overall, we're getting good feedback. It has been a very positive project, and like they are also reaping the benefits of this particular installation as a pilot. Like when you do a community, you'd probably organize it differently, but literally the solar panels are hooked up to that particular account. So it is being net metered on a local unit basis, which basically means they're the ones reaping those benefits. So as for living through the science experiment, they are getting the benefit of that pilot's energy savings. But in the future, once again, like you say, we own the asset. And in this particular building, we didn't used to pay for the heating, right? The natural gas was paid by the tenant. Britannia Woods, for example, we do pay for the heating, and we pay for all the natural gas. So we actually already have control, quote unquote, of the heating. So that one actually lends itself, when we get into these larger projects, it actually lends itself much better to the types of control. Is just for the pilot, not every single aspect of the financing is going to line up.
Yeah, right on. And in terms of sensors, you talked a lot about all of the sensors, the myriad of sensors that are throughout the panels themselves on the outside of the building. Did you also measure indoor air quality? Like, do you have the ability to say, hey, there's a tangible change in the quality of the air inside these suites?
Yes and no. So we have CO2 monitor. CO2 monitoring is the way that we're approaching it, as well as temperature and relative humidity. Now, I mean, the caveat of having occupied buildings and obviously having people living in the buildings is behavior. And although this is a super high performance building, for example, I went to this place during the winter. There were windows open throughout the winter, regardless of how cold it was outside. And so, for example, we talk about indoor air quality. I know that the CO2 has been fantastic in those in those units. I want to say that it's because of the ERV, but I also know that there were windows open throughout the winter. Similarly, when I look at some of the energy, right now we are on par with meeting our energy targets, which is fantastic. But then I also go to my mind, well, man, we could have done this even if people kept their windows closed. We're actually overproducing if in fact we're also heating the outside as a result of this. So yes, we were talking about the benefits to the tenants at the beginning. Tenant behavior, how somebody is going to run a net zero house can make it not a net zero house. It's been a very big education piece, and it will continue to be an education piece because that energy budget, if you will, that we have, they're the ones with that credit card, and they get to charge it every time they flick on a light or every time they open a window. We're just trying to provide the absolute best building. And really, at the end of the day, how it's operated is whether it's going to end up being net zero or not.
Yeah, you bet. And I think the same conclusion was drawn last month's webinar when we talked about cold climate heat pumps. And because because you're looking at some of the energy charts and how the buildings were performing, and somebody said, "Well, what's that?" I said, "Well, we know." So yes, we tried to remove all the natural gas, but they had a natural gas fireplace, and we know that they use it, and they use it a lot, right? So it's you kind of you can't engineer or plan around behavior necessarily, right?
And not only that, we originally had anticipated a 21-degree temperature, but that's where I keep my house. Some of the tenants wanted at 27.
Yikes!
And that, I mean, that's cooking in my opinion.
Yeah, no kidding.
But like we ended up landing at 25, which is still a pretty big number. Especially anyways. So yes, that aspect of the how it's going to be operated and tenant expectations for what comfort means,
Right.
definitely is going to change that energy budget.
Yeah, right on. Hey, let's move. Oh, go ahead, Rob.
Sorry, yeah, no, just a follow-up question, just tying into that, that you brought up last month's webinar on heat pumps. So is fossil fuel, natural gas completely eliminated from the site?
Completely eliminated from the site. It was a really fun phone call that I got from Enbridge, where they called me the morning of, and they were like, we're here to remove these meters. I said, absolutely, rip them all out. I was like, there's people inside, right? And it was October, it was end of September, and we're going into. I'm like, we've already installed heat pumps. You're all good. Rip them out.
Yeah.
So
right on.
No more natural gas on the property.
So how was there a low temperature cutout for those heat pumps, or what would you do for kind of peak heating demand?
Yes, exactly. I mean, as we get into those negative temperatures, at one point the furnace just has an electric resistance heater, and it just kicks on and it takes care of the rest, right? And ideally with our high efficiency building envelope and the ERV running, which is another aspect of that tenant behavior piece of making sure that ERV stays plugged in and always running. But yes, after a certain temperature, we're effectively just the electric resistance, and that heat pump is just in standby.
Okay, right on. Hey, we talked earlier about the authority having jurisdiction from a building perspective. Now, what about hydro? So now you've taken out the natural gas, so you get rid of all of that kind of winter peak mitigation for the electric system. Did you have to do some education with hydro to reassure them that you weren't going to cause a problem?
Well, so as opposed, we're in constant conversation with hydro, because I look at this and I say, hey, I've got this funding. We're going, like, OCH has this funding. We're going to be doing this, and we're going to be electrifying because we're eliminating natural gas. We think we're going to break your grid as a result of that, because just for this one project, we needed to go up to 125 kVA transformer, and that added, and upgrade all the panels, and that added $50,000 to this overall project, right? That wasn't necessarily anticipated. So we are in constant conversation with our contacts, as well as trying to get the conversation higher and higher, because we recognize that there is no way that we're able to do these retrofits at one. If we just said, hey, we're going to do 100 of these, we probably wouldn't be connected right now unless we try to find a way to do that mitigation and that planning together. And here's the thing. In this particular project, we just talked about Enbridge. We disconnected Enbridge. They lost a customer. We became our own utility company by having these solar panels that we now have to maintain and do all that. OCH is not in the business of being its own, of being a utility company. We want to manage the building asset. So what they're actually, the reason that I want to stay in conversation with the utility companies is that there is a beautiful business model there that says, no, you guys could be owning these heat pumps. You could be owning these solar panels. It would reduce OCH's capital cost. And you could maintain, operate, and sell us BTUs, or sell us kilowatt hours the way that you already do for hydro. But then it maintains that partnership. It maintains that client approach. Like, we remain a client of Enbridge, because now they're just selling us BTUs instead of cubic meters of natural gas. It alleviates this pressure. Like, it adds a stress. It adds we now have 4 heat. Actually, we've got 8 heat pumps, including the domestic hot water tanks that we've had to add to our operations. And it's not something that our current mechanical contractor is familiar with. Similarly, we've got to maintain that 35 kilowatts of solar. So having as we move forward and do the next 2,500, 2,400 units, we're really hoping to find those partnerships with the utilities or with third-party utility providers that have that creative business model that helps reduce the capital costs on our side, but also doesn't eliminate these client or partnerships with utilities.
Yeah, equipment as a service.
Absolutely, yes.
Yep. Yeah, right on. That's cool. So you alluded to this earlier, but I guess this might also that strategy or that notion might also apply like in the Britannia Woods type of a solution where you've got all of these units and you started contemplating about things like plant. Like maybe we don't have to do a distributed model, maybe we could do a centralized model. Would you then consider looking for a service provider to say, hey, give me the plant and give me the BTUs and sell me the BTUs? Is that kind of where you're leading?
Absolutely. I mean, so when we look at Britannia, we're talking about we're talking over $30 million potentially for when we wrap a bubble around everything, right? Very much, how much, yes. There is a path that OCH says, you know what, if I could save $10 million on that one, I can go and do this at this other building, or right, we've got to manage a bunch of priorities to get as much work done in those 10,000 units overall. So figuring out a model that would say, hey, the mechanical and the solar assets could 100% be capitalized by a third-party utility provider that's going to manage, own, operate, sell us BTUs. And that actually becomes a really, like, as opposed to one little 4-unit block, I would imagine that a 1 megawatt of solar with 179 units worth of heating becomes an actual project that's attractive for a 50-year, 70-year amortization period for somebody to capitalize and enter into a partnership. So absolutely, as we're designing that, we are keeping the door open because that represents, I'm going to call it savings, but we can focus on the building and keeping the building envelope and that asset standing, while the mechanical partnership or electrical or whatever, or utility partnership could provide that heating in a similar model as it exists now.
Yeah, that's awesome. That's awesome. So I just want to segue one more time towards cost, because of course that, for most people that are lingering on this call and listening to us chat about this, they're probably thinking, well, can I afford to do this in my portfolio or my building? So you did life cycle costing. I'm so happy to hear that you guys have focused in the life cycle, because I've been advocating for that for a while now, that simple payback is just not the way for us to be justifying or even considering these projects. So you did 60-year life cycle costing, and if I understood correctly, you've got your first costs and you've got your operation and maintenance costs. So any replacements along the way, if that heat pump needs to be replaced in 15 years, you're accounting for that in your analysis. Do I understand that correctly?
Yes, 100.
Awesome.
Yes, you have to. Yep.
Okay, so you've got all of that, which is fantastic. Now, this project, was success hinging on incentive?
By incentive, you mean
funding incentives. So government incentives or utility incentives. Like, was that windfall of dollars, grant or otherwise, required to make the 60-year life cycle math work?
No, sorry. Okay, perfect. The cost in that total cost of building ownership is the cost.
Okay.
We're not taking away the $500,000 that we got from Natural Resources Canada. It is just the cost. And so the cost is composed of the grant that we got from Natural Resources Canada and the OCH Green Fund contribution in order to make the project happen. We're not taking away anything. Okay. That being said, however, when I presented this project early in the process that said, hey, we're working with we've got a design, and we'd like to go and spend about $1 million on doing this. It was like, yeah, we'll think about it. And I'm like, it's really important because we're probably going to need to do this in other buildings, and it would really be, well, when then you walk into the CFO's office and you say, we'd like to do this project, and we went and found $500,000, and it'll only cost us $500,000 to do this project that we probably really need to do anyways. That really helped grease the wheels and get it approved.
So what you're saying really is we still have to find a way to break the traditional model of project financing, or even in our understanding of what value is. for this type of project, right? Because first costs are still limiting. That's what it sounds. That's what I think I'm hearing from you. First
Well,
costs can still be limiting.
I mean, we talk like our own homes, right? Like who thinks about their house in a 60-year life cycle? Unfortunately, right now, I mean, you probably can't find a homeowner that has that type of horizon. Private developers, you're probably not also talking, you're probably maybe in the 20, the more like established ones that see the long-term range, but you might be getting down to even the 5-year turnaround. Housing providers, however, in one incarnation or another, like OCH in its current incarnation was 2 different housing providers back in 2003, and were for 40 years before that, they were separate. So these public assets in some form or another will be managed by an OCH version for the next, I mean, they are funded for the next 60 years. So that's why I really find it's a good place to catalyze this market, because we have the luxury, if you will, of looking at it from a 60-year life cycle, because some version of us and public funds will be managing and operating these buildings for the next 60 years. So as good stewards of those public funds, we can do that long-term evaluation and say, yes, we want to save $500,000 or $1 million over the next 60 years, because that $1 million can go and fund the next project as well.
Yeah, I think you've nailed it. I think you've nailed it, because everybody's looking at this from a different angle, and you're right. I mean, I have a fairly efficient house, but I can't even fathom, what it would take to convince my CFO, to spend $50,000 or $60,000 to retrofit our house with something that we don't already have. And I think I'm not the only one that probably sits into that category. And I'm hearing that in the marketplace. Seasoned energy engineers who have done the math themselves, and they've said, I'd really like to get rid of my natural gas meter, but the cost for me to transition to all electric, I can't stomach that initial cost. I recognize that over the long haul that it's going to make sense. But I also know that I as a person or as a family or whomever may not see all the benefit, right? If we don't own the asset. So there's some challenges, but I like your idea, your notion that the sector you're working within could be the bench, the test bench, to prove the process, to refine the process, to figure out how it works best, to figure out what kind of funding model needs to be there, incentive model to make it work for others. And to use that to move forward. That's a great idea, Dan.
And then, PACE models, right? Like with municipalities or even government. So let's say that, after OCH has 1,000 units under its belt, the city of Ottawa says, okay, we're going to make this pot of $20 million and we're going to find communities of single family homes or something like that. We're going to run the line down and that will be amortized on everybody's property taxes over this period of time. That's going to be amortized from this federal fund that is that is funding itself from the GHG auctions over a 50-year period. And in all honesty, I know that it's a touchy subject, but putting a price on carbon, the negative externalities that our carbon emissions have, we have to price those in somehow, or else we're literally just kicking the can of that problem very far down. Well, not even that far down the road, as we're seeing, and our kids are just going to have to deal with it.
Yeah, you're not wrong. There's a cost to doing nothing, and that's something that as a society we're probably going to have to come to terms with sooner than later. Yeah. So we're actually over time, but I don't want to stop the conversation because I'm having so much fun. But I want to ask one more question before we close it down, and this one is more of a soft question. So, in terms of education pieces, you've done this pilot project. You're talking about a whole bunch of other things. Some of them in very tall buildings, some of them in short buildings, some of them in communities. What education pieces do you have in place, and how did your experience at the President site build or help you build those education pieces?
So are you talking about with tenants or with the industry, with my corporation, or
How much time do we have?
No.
So I think the first would be the tenants, because you're impacting their home.
Yes.
Which they have no control over or very little control over. So I think that's where I'd want to start. Of course, the other ones I'm interested in too, but maybe we'll have to save that for another time.
So how about this? When we started the project, we made this document. We had an energy facilitator, somebody who's like we had somebody on staff whose job was to go and talk to people about energy. There's also language barriers. These are vulnerable populations. So there were lots of pictures. We tried to give them a schedule of what would be happening. And like a building envelope retrofit doesn't probably mean anything, right? So it was like, well, we're going to be doing this. We're going to be doing this to your windows. We're going to be doing this to your furnace. Try to explain as much as possible. So that they understand why they're opening that door that day and why there's trucks rolling around in their community. And then like it was chats I tried to have an equation that said 1 week before we do something on site, I need to go and knock on a door and say, hey, this is going to happen next week, or make sure to chat with at least a couple of them, even though technically all they were supposed to get is a 24-hour notice so that they understand what's going on. And then it was an education piece of how to use the equipment, how to actually, like, you don't need to open your windows. You should be keeping that heat recovery ventilator online. And the answer there is just that's one, it can be a societal thing because nowadays everybody understands, well, most people understand like a thermostat. They've got some, like, I believe that as we incorporate these things more into our general societal lexicon, hopefully the overall energy knowledge goes up. And it's going to be, when we do this with our 2,400 units, there's going to be a dedicated staff. In fact, probably a dedicated group of staff who will just be doing that tenant and engagement piece and just, this is what's coming next week. This is how you use this. Call me if you have any problems and all that. Similarly, my CFO doesn't necessarily understand, well, what does the heat pump do? In fact, she doesn't need to necessarily understand, like her job is to make sure the dollars make sense. So it's my job to translate this heat pump. Yes, it costs $2,000, but it saves this much over 20 years, right? That is what our CFO needs. That's the information that she needs to make her decision. So it's translating this technical information into that education of what the different parts of the organization. And similarly, my property manager needs a different piece of information because he's like, what is this piece of equipment that I've never seen before and how does it operate? Yes, and then the last piece, consultants and things like that, I'm hoping, and I have no doubt, especially with the association, every time I go to one of the conferences, like we have people who are hungry to do this. So I don't think anybody there needs to be educated. It's more informed that, oh, people are interested in this product. Absolutely. I'm here talking about OCH. I can assure you there are 3 other large housing providers in Ontario that are aggressively pursuing this type of project as well. So anywhere in Ontario, you have, if you're interested in these types of projects, you've got a housing provider that's not far who wants to hear from you. That's a little bit of my pitch.
You bet. Well, listen, Dan, thanks so much for making the time for us today and answering the questions so well. The conversation's been really fun. Like I said, I'd like to keep on for the rest of the morning, but unfortunately, we all have day jobs.
We do.
So thank you for everybody who did linger all the way to the end. I think we kept almost everybody that was here from the beginning. So that's a testament, I think, to the interest. I think this is a great stepping off point for many of us, and I would encourage anybody who's watching to reach out directly to Dan if you remember his contact information. The recording will be available for those who are interested in watching it again or sharing it with friends. We're going to ask if Dan will allow us to share the slide deck as well, so we'll PDF that and get it ready for you too. We have some more webinars coming up in May. I didn't have time to throw them up on a slide, but watch out on our LinkedIn page. If you don't follow us already or like us on or whatever, follow us on LinkedIn, please do. That's probably the easiest place to get information. And Dan, again, thank you very much. Have a wonderful day. Enjoy the weekend. We'll talk again soon.
Happy Earth Day, everyone.
Happy Earth Day. Great timing. Thanks, Dan.
Cheers.
Thanks very much, Dan. Take care.